Let's take a look and talk about a notching application in RandomView, a module of VibrationVIEW. So notching is the ability to take a response channel and notch the entire channel to a certain value or notch a certain frequency range of that response to then take over as control if my channel violates that notch. So we find that setting in our edit test settings. So I'm going to edit test. For this application, I'm going to actually run the test, and I'm going to pull out my notch information from a response. So I'm in my advanced test settings, and I'm going to click on my notch tab. And I'm going for channel 2, and I know channel 2 has a resonance, and VibrationView's demonstration mode shows me this resonance. And I have some options just to notch at a certain dB relative to control over the entire frequency band, or I can choose a notch table. I can do the same thing with the aborts. So in this case, the test would stop if I choose an abort, but a notch will simply notch out that section and the test will not abort. On the other end, the minimum control values, instead of a notch, we can actually do the same thing with a boost. So we could actually boost a signal that is not responding the way that we want. But in this example, I'm going to stay with the notch. And I'm going to show the notch table. So from the notch table, I can click on this input button. This is going to replace my entire breakpoint table with channel 2's response. So this is a mirror of channel 2's response, which is over here. But I maybe don't care about this entire frequency band. I possibly only care about maybe 375 hertz to 550 hertz, let's say. I'm going to go to my table here, find the closest frequency to 375. We got a 372.5 here. And I want to get rid of all these 137 values above here. So I'm going to hit the first button. The software will delete all the values before that frequency. And now I wanted to go maybe to 550 hertz. So I'll click 551 or 563. 551, let's go for. And when I hit the last, it will get rid of all breakpoints under 551. So the software has already calculated that this peak is 10.29 GRMS. Well, I don't want that peak to be so high. So a very quick way I can get a smaller peak is to scale this. So I can scale this breakpoint by RMS percent or dB. I'm going to actually scale this down to 5 GRMS. So I've scaled it down. Clicking OK is the same as clicking apply and OK. So I click OK here. And when I edit my graph, I actually have the ability to turn on my notch channel, or what that notch looks like. So as we can see here, and I can right click and zoom in, we can see this is my notch, and now this controller is slowly notching the control trace, which was here, is slowly notching that down, and this appears to be a lot longer than it's actually happening because this PSD has this 120 degrees of freedom built into it. But after a few moments, I can see that my channel 2's peak has been notched down to what I've defined it, and I can see that in this picture I'm violating my lower abort for my PSD, but when notching is active, this lower abort in the frequency section is ignored, and I can actually see what my drive signal is doing. It's notching out because channel 2 was violating this response. So the advantage of doing this notch while my test is running is I can get a response, quickly paste that response, and set up my notch more easily. Disadvantage is that the level is actually going to get that high until I apply my notch. So I can apply this notch beforehand if I have some idea of what my response will be. But here's our application for creating and applying this notch in random. Thank you for your time.